The question says that predict the direction of induced current in the situation described by the following figure 6.15 from A to F. Now there are 6 figures. In all these figures we have to find out what is the direction of induced current in the coil upon either a moving magnet or there is change in current in the nearby circuit. So we will use Lenz law to find out the direction of current, and Lenz law says that the direction of induced EMF will oppose the change in flux that created it. For example, we can see that the demonstration over here, like if the north pole of the bar magnet is coming close to a coil which is stationary, now we see that the flux is increasing, so the current will be induced in this coil such that north pole will be created over here, so that it will oppose the moving magnet towards it, so the current will flow in the direction that would create stronger north pole over here. Now similarly, when the magnet will move away from this coil, then south pole will be there because it will oppose the motion, then it will create a south pole over here so that it attracts the moving magnet and it opposes the movement of the magnet. So let's use this to find out what is the direction of current in each of these diagrams. So in the first diagram we see that the south pole of the magnet is approaching over the Q side of the circuit. So we can see from this figure that since south pole is coming near, so this induced current will be such that south pole will be created over here momentarily, so that the direction, the movement of bar magnet will be opposed. So in order to create south pole over here, north pole must be created over here. So if we apply the right hand thumb rule, we can see that in order to create north pole in the left side, the current must flow through in this direction, anti-clockwise direction, that is QRP. So the direction of current is going to be QRP and Q again. Similarly, in this figure, we see that south pole is moving towards the Q point. So again, the induced current will be produced such that south pole gets created over here and north pole gets created over here. So we can say that from the right hand thumb rule, the current will flow from PRQ in this circuit, and since north pole is moving away from this coil as in this diagram, so south pole will be created over here. So in order to create the south pole over here, north pole must be created over here, and applying the right hand thumb rule, we can say that the current will be in anti-clockwise direction in this circuit, which means that the current will flow from Y, Z and X. Let's move to the next figure. In this figure we have tapping key just closed. Now here tapping, if the tapping key just got closed, it means the current started flowing, and when current start flowing, we see that the flowing current will create north pole over here and south pole over here. So the induced current in this circuit will be such that north pole gets created over here and south pole gets created over here. And by applying right hand thumb rule, we can say that again, in order to create north pole over here, the current should be in this direction, so it should be Y, Z, X. Now in this question we see that rheostat settings being changed. So the pointer is decreasing the resistance, it means the current would be increasing in here, and this axis YZ segment of this coil is much away from us than YX section of this coil. So if the current is increasing over here, north pole will be created over here and south pole will be created over here, and again we can say that north pole should be created in this coil over here and south pole should be created over here. Now since it is much nearer to us, so in order to create the north pole, the current must flow through YXZ, or we can say that the current will flow from, the direction of current will be from YXZ and again Y. Now in this diagram we see that tapping key just released, or we can say that the current has just stopped. Now earlier when the current was flowing, we can see that this wire is hidden from the solenoid. It means that the circular turn is like this. Now earlier when the current was flowing, it would be such that the north pole should be here by right hand thumb rule, and south pole would be here. Now just after releasing this tap key, north pole has decreased, or we can say that the north pole of the magnet has been released. So south pole will be created over here, and north pole will be created over here. And for creating south pole over here, we can say that the direction of the current must be in this opposite direction, or x r y direction. And in this sixth figure F, we see that current is decreasing at the steady state. Now here in this line, the magnetic field direction would be such that the magnetic field will be 90 degree to the area vector of this coil. So we can see in this diagram that if that is the case, phi is going to be 0, as phi is the dot product of magnetic field and the area vector. So there would be no current that is produced in this circuit, in this coil. Thank you.